Hello, I am Mrs. Anjali Nadgouda, lecturer in chemistry, Department of Chemistry, KLS Gokte PU College of Commerce and Science, Belgavi. In today's situation, we must accept the new techniques of teaching and learning because in this pandemic situation, we cannot go outside. So, by keeping our safety, we will face this challenge also. Students, you are always using gadgets like torch, calculator, mobile, tab, etc. Do you know how it works? Yes, it works on battery. So, what is this battery is? What and how it functions? We will get the answers of all these questions in today's topic. So, today we are going to learn the topic unit number 3, that is electrochemistry. As per PU board question paper, the weightage is like this. Part A, 1 mark, 1 question, that is question number 3. Part B, 2 mark, 1 question, question number 12. And part D, 4th question, Roman 4, for 5 mark, question number 29. Chemical reactions can be used to produce electrical energy. Conversely, electrical energy can be used to carry out some chemical reactions. I hope you understand the law of energy. That is, energy neither be created nor be destroyed, but it can be transferred from one form to other form. So, by using this basic principle, we will learn how the changes takes place. So, electrochemistry, the study of chemical and electrical energy and their interconversion, is called electrochemistry. So, it is the branch of chemistry which deals with the study of chemical changes which occur on passing electric current into certain chemical systems, means in chemical reactions, and also with the generation or production of electricity by carrying the chemical reaction. To be more precise, it correlates the electrical energy and chemical reactions, which are redox reactions in nature. The containers or the vessels where these changes are carried out are known as cells. So, what is the importance of this electrochemistry? Preparation of different metals or gases or industrially important compounds. For example, caustic soda, electrochemical reaction. Then electrochemical reactions are energy efficient and less polluting. So this is one more importance. The transmission of sensory signals through cells to brain and vice versa, that is reverse, are known to have electrochemical origin. Means even in our body there are few reactions which are taking place which are having the origin of electrochemical reactions. In this unit, we shall study the various aspects of electrochemistry with reference to the two types of cells. What are these two types of cells? One is electrolytic cell and another one is electrochemical cell. Last year, in industrially important compounds of S block elements, we have studied the uh, the manufacturing of caustic soda by the chemical reactions. Even one more method is there, that is called as Nelson cell method. So there are few compounds in industrially important compounds which can be carried out electrochemically. So what is this? By using electrolytic cell. So in this type of cell, the chemical reaction is non-spontaneous, means it does not take place automatically. It requires some help or some force. It is carried out by passing the electric current through electrolyte. So many reactive metals like sodium, potassium or calcium, etc., or the compounds like caustic soda, washing soda or baking soda are formed as a result of chemical reactions carried in electrolytic cell. Now what is the second type is electrochemical cell. Here the redox reactions are spontaneous, that is which takes place automatically, and the energy released appears to be electrical energy. Example, all types of batteries. So we are going to study in detail about the electrochemical cells. So here it can be defined as this cell converts the chemical energy to electrical energy. Example is the Daniell cell, and this is already we have learned in PUC first year. So in Daniell cell, if you observe, there are two different electrodes. That is, one is zinc rod dipped in zinc sulfate solution, and another one is copper rod dipped in copper sulfate solution. Both the electrodes are joined together by externally by copper wire and internally by U-shaped glass tube, which is called as salt bridge. So this is how the Daniell cell is formed. Now here one electrode acts as anode and another one acts as cathode. And the reactions which are taking place in anode and in cathode are given here. So what are the basic reactions? That is fundamental reactions of electrochemistry. First one is oxidation. Removal or loss of electrons is called as oxidation, and addition or gain of electrons is called as reduction. In this Daniell cell, zinc loses the electrons and hence it undergoes oxidation, whereas copper accepts the electron and it undergoes reduction. So what is redox reaction then? A reaction in which both oxidation and reduction takes place simultaneously is called redox reaction. So zinc plus copper, if we add these two reactions, we'll get the total reaction. The two opposite sides electrons are get cancelled. The terms oxidation, reduction and redox reaction we have already learned in PUC first year. This is just the revision of the terms. Now let us learn one of the example of Daniell cell, that is galvanic. Let us learn one of the electrochemical cell that is called as galvanic cell. An electrochemical cell was prepared for the first time independently by Luigi Galvani and Alessandro Volta. These are therefore called galvanic cell or voltaic cells. So, it is an electrochemical cell that converts the chemical energy of a spontaneous redox reaction into electrical energy. In this device, the Gibbs energy of the redox reaction is converted into electrical work. So, where it is applied? Running a motor or other electrical gadgets like fan, geyser, heater, etc. Example is Daniell cell or dry cell or mercury cell. Now dry cell, I think you understood, the cell which we are using in torch or in clocks. Let us learn few more terms. Anode. In a galvanic cell, the half cell in which oxidation takes place, that is loss of electron takes place, is called anode. So it has a negative potential with respect to the solution. Cathode. In a galvanic cell, the half cell in which reduction takes place is called cathode. It has a positive potential with respect to the solution. Means both the electrodes have different potential. One is negative, another one is positive. There exists potential difference between the two electrodes, and as soon as the switch is in the on position, the electrons flow from the negative electrode to the positive electrode. But the direction of current flow is opposite to that of electron flow. Means if the electrons are flowing from negative to positive electrode, then current is flowing from positive to negative electrode. Now in this view, we will learn few more terms. That is electrode potential. A potential difference develops between the electrode and the electrolyte is called electrode potential. Now, in this case, if you see that diagram, then zinc rod is of solid and the electrolyte is in liquid state. So, there is a phase difference, or we can say physical state is different, and hence there exists a potential difference. Because metal has a tendency to lose the electron, and hence it becomes negatively charged and the solution becomes positively charged. Therefore, two different charges are formed near the rod, and this is called as electrode potential. Now, what is standard electrode potential? When the concentrations of all the species in a half cell is unity, then the electrode potential is known as standard electrode potential, or it is also called as standard reduction potential. Now, concentration of all the species means the electrolyte should be of 1 molar concentration. Now, here in brief it is shown what is potential difference. A battery has a chemical potential energy in the electrolyte in its electrochemical cells. The chemical in the electrolyte react with the electrodes. This causes a difference in the amount of electrons between the two terminals. So this is called, the difference in amount of electrons is called as potential difference. Now what is cell potential? When these two electrodes are externally joined with the help of copper wire, we say it is a cell. So the potential difference between the two electrodes of a galvanic cell is called as cell potential, and it is measured in volts. What is EMF of this cell then? The cell potential is the difference between the electrode potential, that is reduction potential, of the cathode and anode when no current is drawn through the cell. Remember this, when no current is drawn through the cell. The cell potential is called cell electromotive force, that is EMF of the cell. So let us revise once again. The cell potential is the difference between the electrode potential of the cathode and anode, that is individual electrode, when no current is drawn through the cell. The cell potential is called as cell electromotive force, which is also called as EMF of the cell. Now, how to represent a cell? That is called as symbolic representation. Every time it is not possible to draw the structure or draw the diagram and to show the cell. So here are some conventions which are used for the representation of a cell. Anode is written on the left hand side and cathode is written on the right hand side. Of what? Of a double vertical line. You can see here. Anode is on the left hand side and cathode is on the right hand side of the double vertical line. A single vertical line is written between metal and electrolyte solution to show the phase difference. A double vertical line is written between the two electrodes is to indicate the salt bridge. Now what is salt bridge? We have already seen there how it is put in the two solution. Now what is salt bridge? It is a U-shaped glass tube with a gel called agar-agar containing KCl or KNO3. Here the electrolyte which is used should consist of the ions, and these ions should not get mixed or should not get react with the electrolytes used in the cell. Now this is paste-like media. Paste-like medium which is filled in this U-shaped glass tube or gel-like. The transport number of velocities of both K plus and Cl minus ions are almost same. Hence, KCl is used in salt bridge preparation. Now, this question can be asked for 1 mark. Why only KCl or KNO3 or even NH4NO3 can be used for salt bridge? Now, here is the pictorial representation of a cell. So, zinc in solid state, that is zinc rod, then zinc plus 2, that is aqueous, that is nothing but zinc sulfate solution. This completely gives one electrode, that is anode. Then double vertical line shows salt bridge. Then copper plus 2, that is copper sulfate solution in aqueous medium, and copper solid, that is nothing but the copper rod. So this acts as cathode. So anode and cathode are externally attached to with the help of copper wire, and this is how the electron flow takes place from zinc to copper, and the current flows from copper to zinc. So what is the role of salt bridge then? It maintains the electrical neutrality on both sides. It prevents the accumulation of charges in the half cell. One side charges accumulation, it is prevented by the salt bridge. It avoids the liquid-liquid junction potential, that is it prevents the mixing of two liquids. So this is the brief idea about the cell. The remaining part we will see in next class. Thank you and be safe.